let's head on to the most important part, where we'll learn about different types of libraries in Python. So what exactly is a Python library? Well, it's just a collection of methods and functions that allow you to perform many actions without writing the entire code. And Python provides many such libraries. So whatever purpose you have, Python provides a package from its hat. So if you want to do numerical computing, then you have a package named as Numpy. If you want to do visualization, then you've got many visualization libraries in Python. So you've got matplotlib, seaborn, plotly, and so on. And if you want to do data manipulation, then you've got pandas. If you want to implement machine learning algorithms, then you've got scikit-learn. If you want to work with deep learning frameworks, then you've got TensorFlow and Keras. So whatever your task is, Python would provide a package for you. So the purpose of these libraries is for you to not write the entire code from beginning. So it will automatically provide you some inbuilt functions which you can use to make your work even more easier. So we'll start off with one such library in Python, which is Numpy. So Numpy is extremely important for us when we'll further cover all of the machine learning algorithms, because you'll be performing most of the numerical operations on these Numpy arrays. So what exactly is Numpy? Well, Numpy stands for Numerical Python, and it is the core library for numeric and scientific computing. So this Numpy would provide you a multi-dimensional array. So these are basically multi-dimensional array objects, and to work on these multi-dimensional array objects, Python would also provide you certain methods and functions. So these methods and functions are part of the Numpy library itself. So you've got these methods and you've got these multi-dimensional arrays. So you can work with these multi-dimensional arrays. You can manipulate them, you can slice them, you can extract elements from them with the help of all of these methods, right? So whatever scientific task you have or whatever numerical computing task you have, your first priority needs to be a Numpy. So let's go ahead and start by creating a Numpy array. So we've got single dimensional Numpy arrays and as well as multi-dimensional Numpy arrays. So let's start off by understanding how can we create a single dimensional Numpy array. So first we'd have to import the library. So to import any library, this would be the command. So we'll start off by typing import Numpy. So this is the keyword. So to import any library in Python, we would have to use the import keyword, and then we'll follow it up with the name of the library. Now, so that our task, or we can work with these libraries very easily, we would have to give it an alias. And by convention, Numpy is given an alias of NP. So whenever we have to invoke Numpy, we can just type in NP and work with the multidimensional arrays and methods. So over here, I am invoking or importing Numpy, and I am creating a single dimensional array. So we have to type in np.array, and I am passing in a list inside this. So what you see, you have a list which comprises of the elements 10, 20, 30, and 40. And you are converting this list into a Numpy array and you're printing it out. Now this, what you see, is a Numpy array. So this is a single dimensional Numpy array. You can also go ahead and create a multi-dimensional Numpy array. So if you have to create a multi-dimensional Numpy array, so instead of giving in a single list, what you'll do is you'll give a list of lists. So as you see, you've got a list over here, and inside this list, you've got two lists. So the first list comprises of elements 10, 20, 30, and 40. And the second list comprises of elements 40, 30, 20, and 10, right? And when you give this inside the method np.array, this will give you this multi-dimensional array. Now let's go ahead and create these two single dimensional and multi-dimensional arrays in Jupyter Notebook. So I'll start off by importing the Numpy library. I'll type in import Numpy. So let me just write this properly. Import Numpy as NP, right? So I have imported the Numpy library. Now it's time to create a single dimensional Numpy array. So I will name the array as n1, and then I'd have to type np.array, and inside this I will pass in a list, and let me give in some values inside the list. So those will be 1, 2, 3, 4, 5, and 6. Now let me just go ahead and print out n1 over here. So this is what we have. Now just to be sure, let's go ahead and check the type of this n1 object over here. So I'll type in type and I will pass in n1 inside this. So we see that this is a NumPy n dimensional array, right? So this is a single dimensional array. Let's go ahead and create a multi-dimensional array. So I'll name the object as n2. Again, it will be np.array. And inside this, I would have to pass in a list of lists. So I have created a list, and then I will pass in another list over here. So 1, 2, 3, 4, 5, and 6. And then in the second list, I will give in 10, 20, 30, 40, 50, and 60. So we've got n2 over here. Now let me print out n2. So we've got this multi-dimensional array over here. So in the first row, we've got 1, 2, 3, 4, 5, and 6. In the second row, we've got 10, 20, 30, 40, 50, and 60. Now again, let me check the type of this object. So type of n2. We see that this is a multi-dimensional array. So numpy.nd array. So now that we've seen how to create basic numpy arrays, let's see how can we initialize a numpy array with only zeros. So for that, we have the zeros method. So we have to type in np and we can invoke the zeros method by using the dot operator. So all we have to do is type in np.zeros. And over here, we are creating a 1 cross 2 array. That would mean 1 row, 2 columns. So it's a 1 cross 2 matrix or a 1 cross 2 array. And that 1 cross 2 matrix would have only zeros present in it, as you see the result over here. So similarly over here, we are creating another NumPy matrix, which has the dimensions of 5 cross 5. So, and you see all of the elements are filled with 0. So you type in np.zeros and inside that you'll just pass in 5, 5. So you are just giving in the dimensions of the matrix. So let's go ahead and work with this in Jupyter Notebook. Again, I'll start off by invoking the library. Now I'm just doing this so that you guys have more practice. So import numpy as np. So now that this is done, let me create a new object over here, n3. And since I'd have to initialize this with zeros, I'll type in np dot and I'd have to invoke the zeros method. So I will start off by creating a 2 cross 3 matrix. So I'll give in the dimensions inside this. So I'll just type in 2, 3. And let me print out the values of n3 over here. Right, so this is a 2 cross 3 matrix. We've got 2 rows and 3 columns and all the elements are filled with 0. Now I will go ahead and create another matrix over here, n4. And this time let me create a 6 cross 6 matrix. Again, I am invoking the zeros method and I'll pass in 6, 6 over here and I'll print out n4. So this is a 6 cross 6 matrix. So we've got 6 rows and 6 columns and all of the elements are filled with zeros. Now we'll see how can we create a NumPy array or initialize a NumPy array with the same number. So for that, we've got the full method from NumPy. So over here, we are typing np.full and this has 2 parameters. So the first parameter is the dimensions of the NumPy array matrix. And then we will give in the value which would be filled inside the matrix. So over here, we are creating a 2 cross 2 matrix. And then the second parameter is the value which has to be filled inside this matrix. So 10 is filled inside this 2 cross 2 matrix. So let me just create another object over here. I'll name it to be n5. So I'll type in np.full and as we've seen, this takes in 2 parameters. So I'll just give in a comma over here. So first I'll give in the dimensions. So I want to create a 3 cross 3 array matrix over here and I'll pass in values. So let's say I want the entire matrix to be filled with the value 5. Now let me print out n5 over here, right? So we have a 3 cross 3 matrix where all the values are filled with 5. Similarly, let's say if I want to create another matrix, so I'll name this matrix as n6, again np.full. Now I'll give in a comma over here. I'll give in the first parameter. I want a 3 cross 6 matrix and I want 9 to be filled inside this. So let me just print out the values of n6 and as you see, we've got a 3 cross 6 matrix where we've got 3 rows, 6 columns and all of the elements are filled with the value 9. Now we'll look at the next example. So we've got the arange method. So this is what we use when we'd have to initialize a NumPy array within a particular range. Now here I am initializing a NumPy array within the range 10 to 20, right? So I will use np.arange, and what you see, the first parameter over here, this is inclusive, but the second parameter is exclusive. So we have the values which are starting at 10, they'll go on till 20. When I say go on till 20, it will stop at 19 but not include 20. Now if we also have to give a step to it, right? So let's say over here, I have the value starting at 10 going on till 50, but the increment or the step is 5 over here. So we have 10 and then you add an incremental value of 5, you get 15. Then you add 5 again, you get 20. And this goes on till it reaches the value of 50. So again, since 50 is not inclusive, you have 45. So when you add 5 to 45, it becomes 50. So that is why this array stops at 45. So let's go ahead and work with the arange method. Let me name the object as n1 over here, and this time I want values starting from 1 going on till 50. So np.arange, and I'll type in 10. Now I actually want 50 to be included in the list as well. So what do you think would be the value over here? It's obviously 51 because it will stop at 50. Arange, and I'll type in 10. Now I actually want 50 to be included in the list as well. So what do you think would be the value over here? It's obviously 51 because it will stop at 50. I'll click on run over here. Let me print out n1. So as you see, the values start at 10 and they go on till 50. Now similarly, if I want to give a skip value, so I'll type in n2 over here, np.arange, and I'll give in the first value. So I want all the values starting from 1 going on till 100, and I want a skip value of 10. So let's see what do we get. I'll also print out n2 over here. So we've got 1, 11, 21, and this goes on till 101, right? Because you got a skip value of 10. So 1 plus 10 becomes 11, 11 plus 10 becomes 21, and this goes on till you reach 101. So when you add 10 to 101, it becomes 111, and obviously it overreaches or it expands the value of 105. So that is why it stops at 101. Now we'll see how to initialize a NumPy array with random numbers. So we have this random method, and inside this random method, we've got the sub method, which is randint. So we have random integer values. So again, first you will give in the range over here. So 1 to 100. So within 1 to 100, you are extracting 5 random numbers, right? So you've got 3 parameters. First is where the list starts, or basically your initial value to choose from, and then you'll give in the upper limit. So you've got the lower limit, you've got the upper limit, and from this range you will give in the number of values you want. So I want 5 values within the range of 1 to 100 over here, right? So you get 5 random integers between 1 to 100. So let's go ahead and work with this. So again, I'll name the object as n1 over here. I'll type in np.random, and after this I'll type in randint. So let me give in the initial value, which is 100. So the lower limit is 100, and then I'll give in the upper limit. So I'll give in the upper limit to be 1000, and I want 10 random values between the range 100 and 1000. Let me print out n1 over here. Right, so these are the values which we get. Now, every time I run this, I'll get a different set of 10 values, right? You see the values are changing. I'll click on this again. You again see that the values are changing, right? So as you see, whenever I run this, I get a different set of random values which are stored in n1. Now we'll see how can we check the shape of a NumPy array and also change the shape of a NumPy array. So here we are creating a multi-dimensional NumPy array. So I have created this array where these are the values, basically 1, 2, 3, 4, 5, and 6. And initially we see that the shape is 2 cross 3. That means there are 2 rows and 3 columns. Now, if I want to change the shape of this, so from 2 cross 3, I would have to change it to 3 cross 2. all I have to do is invoke the shape method. So I'll just type in n1.shape, and then I'll assign the shape which I want to assign to this numpy array. So initially it was 2, 3. I want to change it to 3 cross 2, and that is what I'll assign to n1 array. So let's work with the same example. n1 equals np.array, and I'll create a list of lists. So I've got 1, 2, and 3. Then I'd have to create the second list over here, which would be 4, 5, and 6.